Good morning, good afternoon, good evening. Welcome everybody to today's session, CI/CD with OpenShift in large, highly regulated enterprises. We're hosting two sessions on this subject. The first one was Thursday last week, and in this week's session today, in last week's session, we showcased how to build a microservice-based application with OpenShift. And in today's sessions, we will automatically create a stage environment with a custom Jenkins pipeline out of OpenShift. Our speaker today is Felix Knöpke. Felix is an experienced solution consultant with a background in PaaS and SaaS solution design. Prior to T-Systems, he worked for various Berlin-based PaaS startups. For those of you guys who don't know T-Systems, it's the corporate customer unit of Deutsche Telekom, one of the largest telecommunication companies globally. A few logistics before we get started. If you have any questions, please submit them via the text chat as we go. Felix will answer them at the end of our session. This session is going to be recorded, and we will send out the URL within the next 48 hours, along with the URL from last week's sessions, just in case that you missed it. So without further ado, let me hand over to Felix. Felix, the stage is yours.
Thank you, Raphael. So I welcome you as well. And yes, I just start with a short agenda. So we will start with a very short recap of last week's outcome or what we achieved last week. Then I will dip in the pipeline theory and idea we have behind it, what's possible and how to design it. Maybe then we go into a project-based CI/CD approach to set up stages, how to set up those pipelines, and then we do it live. So without further ado, let's go ahead to the short recap. The application we're based on, or we will use for this CI/CD example, is a microservice demo application. It's called the SOX Shop, and is from Webhooks. We've chosen it because it's an independent third-party provider who created the demo that should showcase microservices application. We just adopted this application to our OpenShift environment, and to showcase how easy it is to set up a microservice-based architecture and deploy it in a very short amount of time. So that's like the topology of the application we did deploy. We have a front end, we have the orders, which includes a lot of special microservices, each focusing on a specific part of that e-commerce shop, and the catalog, which is the second part. Everything else together in the front end for the user, and well, that's it so far. I would like to jump over the final outcome we did achieve. So we did create 3 projects, which is kind of a resource aggregation within OpenShift. And we just filled in the dev project, which means that we have a specific namespace or a specific area where we can develop our core application, where we have like a user management within and a resource management within. That's everything we have in dev. And like you see, or as you can see, we have a running application in here, which consists out of several microservices. We have run one specific route here, which just help us load the microservices application. So that's what we did. So let's assume that this would be a live or real project, and we finished a specific state of development where we can start with like deeper testing or release preparation. So in this case, we want to build up a staged environment, which enables us to separate all the testing or even the productive environment from our development environment, where we always will be on the bloody edge, develop latest and platform parts, core parts, and those shouldn't influence the live or productive parts of the platform. So there we just split up environments, and that's why we have specific namespaces or projects to just do all of those things in. Also, we have a central pipeline project, which will contain all of those middleware components that will help us navigate through the stages and so on. So back to the slides. Okay, so far for the recap of last week. Let us dip into the more theoretical part of how to handle the CI/CD. What does it mean? How to achieve it in OpenShift. I have those colored background items, which is the yellow one and the two gray ones. Those would indicate projects / environments. So, which I have on my single platform right now is are 3 projects, which is Project CI/CD, Project Dev, and Project QA, as we've seen in the web browser a minute ago. What we also can do is to communicate with other platforms. So for a real scenario, it would be that we could put the dev and QA platform environment on the same platform, just divide them by dividing the environments with our namespaces and projects. There we can map different users on and have specific user management, roles and rights management. So we separated those environments just logically, but not physically. But we also can separate them physically by creating an own prod platform, which is not in scope of today. Today we will cover how to stage to QA, but it would be nearly the same if we go to prod. We would just talk to another cluster at this point later on. But just for you to understand, this is a way we could build up a CI/CD pipeline, which would put or help us to bring our application or platform to the final productive step, even just automated and not with a lot of manual setup before. The one project, which is called CI/CD, is highlighted in the yellow version because that's like the wrapping element of our whole pipeline. Because within this project, we would manage the stage transfer of images, and we would manage like any other helping middleware service that we could inject in our platform. For example, we discussed last week a question from a user who asked if we also can use Nexus. And in this case, we could have like an artifact repository for Java build applications. We can use their Nexus as standard artifact repository, but also we can use Nexus as proxy repository. And we will host it in this specific toolset area or toolset namespace, but each application can use it while building. So maybe while the build of an image, the container out of the dev namespace would request images through the proxy repository in the CI/CD namespace, will download it, and so on. So we will cache it there, but the project itself is not distorted or something else by specific application parts that do not belong in this application specific namespace. So that will help us a lot. Also, we could put stuff in like a source code management system, for example, a Git and so on. We could put in the Jenkins, which help us doing the pipeline. It's also part of today, but Jenkins does a lot more since it's a framework for like testing purposes and like just this usability stuff. In our case, it will orchestrate the image flow from one environment to the other and show it as a pipeline. So the most important thing for all of those, or for the whole constraint or platform setup, is the image concept. We are building on top of Docker images, and the beautiful part about Docker image is that it doesn't matter where you spawn up an image or a Docker file, it would behave the same on any platform if you have the image available. So we can just verify at a specific time point in our dev environment that this image is functional, and this image is what we will use in other stages or in our productive platform later on. So we could tag this image with a specific tag, and use it wherever we want to use it. And that's what we're going to do today. We're taking an image, putting it in the registry of another project, or just linking it there, and then deploying this image with a specific tag. And later on, we could grab that image from an image registry, transfer it to the image registry of a productive platform with that specific new tag, and then deploying that image there. And since the Docker image behaves anywhere the same, we could be sure that the platform will behave the same in this environment. That's the core logic behind the situation we have here. Yes. So what are we going to do? We have that microservices build application. We have a lot of microservices and a lot of images that are well available. So if I go to our platform, to the dev project, we have the build images. And this is, well, the state that we're using here. It's the latest tag or specific tag of RabbitMQ and Golang we're using here. And those are the images we would use anywhere else, but not as the latest tag, because that indicates that's work in progress and continuously renewed. So we're tagging all of those images at one certain point in time with a specific version number. Who is doing it? Our Jenkins. So we would spawn up a Jenkins. This Jenkins takes all of those images, tagging it to version maybe 1.0 or a specific other version number. Then Jenkins triggers in another project a specific deploy command. It triggers the deploy of all images with the tag version 1.0. In this case, we would spawn up the whole platform we did set up in another project in our new project. And we do not have to execute all of those steps, which took roughly about an hour or maybe longer in the other environment, because maybe we need to figure out how specific things start to work. We don't need to invent the wheel twice. We can take use of all of our effort to move those images there. Yes, this is the first step we will do here. Back to our platform. Have a look in our pipeline. It's clean. We have nothing in here. Also build and pipelines, there's nothing. Also, we have the QA platform, and the same here. The project is blank. We have no resource in here, no images, nothing. That's the point where we're starting. So all we need to do to create a platform or a pipeline is this command. Let me explain in short what this command will do. This command will create a new application, and what we set up is like a stage pipeline YAML file. So we create a configuration element. It's called pipeline. It will create a pipeline, and we will create it in the namespace CI/CD Jenkins. What we also did is parameterize it. To understand why we do parameterize it, let me jump into that file. The file itself just is a typical template file of OpenShift. And what we do is we create a stage pipeline. That's our label. Our pipeline is from the type build config, but it's a specific build config. So it has another tag, which or an annotations, which indicates that it is a Jenkins specific build file, and it's a pipeline file. So far, so good. The more interesting part is what's coming here. We have the build strategy, which is not like from Docker file or from source code, which is Jenkins build pipeline strategy. It's a very custom way of building images. In this case, we're executing whatever is written in the Jenkins file. Every one of you who use Jenkins will see specific things here, but which is more interesting are the fact that there is also an integration into Jenkins by plugins, which enables Jenkins itself to communicate with our platform. we have the OpenShift tag and the OpenShift deploy commands, which just help us or help Jenkins to do things on our platform. So let me explain in short. We have our parameters we set in our command early. Here we just echo them to verify that everything is in place that we want to have there. And then, as I've shown, we tag everything that or every platform component we have here with our user that has the latest tag, as well as the specific RabbitMQ and Golang image with a new tag. So there, again, we have a version, and final version that we put here as tag. And then we change up the tag via SED, just change them up there, execute the command, we tag them with a new version number, which is here. Then the SED command is just to change the platform names from dev to QA. And well, then we create, so what comes out here is a YAML file, and we just create it, a namespace. That's all. Then again, we expose a service to have a route to the outside, and that's everything we do here. Tagging in another environment and execute that we have now the deploy command. How easy it is? Showing here. So first step, create the pipeline itself, which does not mean that we execute it. We're just creating the pipeline. So give it a second. So now I go to our pipeline environment, and we see, since we created a pipeline, but there was nothing to track the pipeline in, and there's just a Jenkins integration, the system itself does spawn a Jenkins container, which will populate it by the configuration we've just chosen there with the Jenkins file. Also, what we did create was a pipeline. QA pipeline, the name. And if we go inside, we can see the configuration, which includes the Jenkins file we went through. Of course, we could do all the steps on our own in the console. We could otherwise script the console to do all of those things, but it's easy to track it by pipeline if you want to see logs, if you want to execute extra steps, because that's a very pure version of just bringing the images from one environment to the other. But you also can add specific extra steps in between if you execute just a Jenkins file, but if you want Jenkins to do further steps. For the whole staging environment, it's not so important to have further steps, but later on, if you do specific platform parts or something like that, maybe you want to trigger unit tests, integration tests, stuff like this, that are executed by Jenkins itself. So back to the overview. Also, we see that the pod already started and our environment is happy to go. So now I could start with executing the pipeline. I go back to build pipeline, enter the pipeline, and then I just trigger start pipeline. So now I could just go to logs and I'm redirected to Jenkins. With my Jenkins, I could log in. OpenShift single sign-on. And so you can see it's just a standard Jenkins we are using here, using specific plugins to communicate with OpenShift. Those are already merged into the base image we have here, but you also could just download the plugins yourself and using your existing Jenkins instance for that purpose. Also, we defined steps like tag images, export the configuration to the YAML file, and then executing the YAML file, which just creates the whole new platform. I also could keep track of what is done here by going to the QA environment. And I see, well, there are some services spawning. I can go to deployments. And I see now every component is pending without any work I put into there. So also I can go to the images to see what images do we have here. We use the tag 1.2, and we see every image that we've used here is available with a new tag. And we could go on from there. So far, so good. Now, that could take some moments until the platform is fully built up. In our very simplistic case, we just triggered all at once. For more, well, let's say, specific applications or sophisticated applications, it might be sensible to navigate the whole process of deploying the images, not all at once, more than one step by step or in a specific order. So now we can see that we have specific or some replicas running. The process of deploying the other ones is still ongoing. Also, we see that on the container side, there are two kinds of containers. The one with a cache code in the end, and those ones with a deploy in the end. The deploy containers are just batch instances that are spawned to keep track of deploying the image and running them on the new platform. So it's a self-contained system which keeps track of everything it's doing itself. If you have questions, I think Raphael didn't mention it directly, please ask them directly in the window in situations like now where we are waiting for the system to finish its job. It might be helpful to maybe answer some questions beforehand to directly go into detail with.
There are actually a couple of questions already here, Felix. So first question is, working with microservices, I want to develop and deploy them separately. What is the best practice?
Again, so working with microservices, the best strategy to deploy them, or?
Okay, just let me repeat. Working with microservices, I want to deploy them separately, develop and deploy them separately. What is the best practice for doing that?
Oh yes, that's the second part. So wait a moment, hold on, because that's what we're touching with as the next time, or not the next time, with the next step we go into it.
There's another question. Is it smart to deploy all images in parallel?
Depends. So normally microservices are not directly dependent on each other. So if we, for example, take the cards DB and cards, of course, cars cannot work without cards DB. But normally it would be this, the way that if you spawn all of them at once and the cards application is up the first, it would try to connect to the, let's say, cards DB. If the cards DB is not up, the service cannot start. So our probe that is normally set will fail. And as long as the probe fails, the container continues to restart and try to reconnect, restart, try to reconnect. If the cards DB won't start in a normal, timely manner, or won't start at all, at some point we will fail deploying the cards application, and we will get a notification or warning that there might be something wrong. But if the cards DB will start, and then the cards app restarted and could connect finally, everything is fine. That's a path-specific way of developing. Of course, you can develop like tiered applications or something like that, where platform parts are hardly dependent on the sequence they're started in. But normally, microservices should be developed the way that this kind of procedure, like we've shown here, is the way to go. So maybe since we deployed everything, I could go to the next step. Like, let's see, do we have a route here? No route. What happened there? I could go inside and do the route myself. So we have in the overview the front end, which should be exposed. It's here. And we could expose it ourselves. Collapse itself. Okay, so the button to expose it myself is not there. I could go here. So I could go to OC project CI/CD QA. So now I'm here, and now I can just OC expose DC for deployment config, run, and sorry, my fault. We don't expose the deployment config, we expose the service. That's easy. So now the front end got exposed. We have a route here. We could go to the route and voila, the application is running. So before I go into detail of how to migrate specific single platform parts, I would like to share, or, well, I think it's not possible because it's not my repository. So the webhook thing I wanted to show maybe another time. So we have the possibility of using webhooks because now I would like to demonstrate what happens if we start develop platform parts our own and just go on from project. So, and just continue developing on them. Let's say we're continuing developing the front end ourselves. We could go to the build config. Go to front end. Go to configuration. And here we find some webhooks, like a GitHub webhook or generic webhooks for other kind of repositories. That's the kind of URL we need to, well, trigger if there is a new build input, like the new branch or the master branch has been updated, something like that. So I would go to this part, front end. And so here I could configure, well, let's see if he edited me. Well, I should do it off screen. So do I have access rights here finally? No, I don't. So yeah, what I wanted to show you is to just add webhooks, but I think that's a thing you could just research on your own, how to add webhooks to repositories. As soon as a new version will hit the repository, then the GitHub, for example, just notifies our platform, hey, come on, I have a new version of your front-end application, so please go ahead and pull it or do something, you know what to do with it. And of course, our platform does know what to do with it because it says as soon as a webhook triggers, start a new build, check out the repository, build an image. That's what will happen. And that will happen to the latest tech. So our development team is always working on the latest tech. So let's say our development team did a lot of research, did a lot of developing, and now we're at a specific other version of the front end itself. So we're advanced, but all the other platform components are not or did not change or shouldn't be moved to another platform because they are not stable yet, something like that. You are interested in just moving one platform component to the new platform part. Nothing as easy as that. Let us create another pipeline for that. So again, we have the YAML file, which defines our pipeline. We have the current namespace where the image does come from. We have the namespace the image will go to. We have a version number we can use here. There are pipelines which are generic, like every time we develop it and we give it a specific tag, please put it there. But in this case here, it's more concrete, like we just want to do version 1.3 that is very production-like. So if you see some other CI/CD examples from Red Hat, for example, they are very generic on triggering pipelines all over to just moving platform components from one stage to another. But here we're referring really to specific version numbers. Then it's easy for your quality assurance manager or other in-between people to track the current stage, to track what happened, and so on and so on. So again, we have specific parameters, and we will create the pipeline within the Jenkins namespace. So let me go over, create the pipeline. Since we now have a Jenkins in our environment, we don't need to spawn another. It's just using what it's given, or what it has given. So pipeline has been created, and Chrome project, come on, pipeline. It's still one and the same with Jenkins. Then I can go to build pipelines, and I see that, well, with the first build, there happened something which he wasn't happy. Thread pool executor. So at least you got notified if there's something went wrong. But as we have seen, everything, oh, okay, some secrets existed since I tried all the steps early on, and it seems like I've forgotten to config elements. Everything else got created, those two existed, so he thought it wasn't successful. In my case, it was successful, but you get notified. It was my mistake. So going back to the platform, yes, he done it, but there's another pipeline which hasn't been executed yet, the front-end QA pipeline for the version 1.3. And now we can start the pipeline. And what he's doing here is we can go to the configuration in the meanwhile. What he's doing is like the stage, set a trigger. So if you can set a trigger if there is a new version for a specific tag. So normally the trigger that is set will say if there is a new image for the same version I have or for the same tag I'm running right now. But since we're dealing with different version numbers, we need to set a new trigger, not for the version 1.2 we used earlier on. We need to set a trigger for the version 1.3, which will come up next. And then we'll do the same with that image. We tag our latest image, which was developed in that, to the new namespace QA for the front end in the version 1.3. So we just create a new instance of an image with a new version, and then we just deploy it there. Or it's not deployed because there is a trigger set, and the trigger says, please deploy if there's a new image version. So go to QA. There we can look at images. And didn't it execute it? Okay. It's still ongoing in the tag. Normally it shouldn't take that long. Don't know why it is doing it right now. Maybe there's another question to answer in the meanwhile.
Yes, sure. There's actually one question. So the question is the following. I am using to trigger my builds Jenkins. Do I have to use OpenShift and the webhooks to trigger my builds?
Normally not. So you have set triggers in Jenkins. Maybe you could specify it a little bit more. Or let me have a look. Do you see it in the front end I can access? Maybe it's easier for me to have also a look on it.
You should be able to see the question, otherwise I can just repeat again. So I'm used to trigger my builds using Jenkins. Do I have to use OpenShift and the webhooks to trigger my builds?
No. In this case, you could just use Jenkins itself. So we have let's say two integrations with Jenkins. One integration is to, well, start a Jenkins, including the Jenkins file, and also triggering Jenkins to trigger something, to trigger a pipeline. Because we started Jenkins, which does include a pipeline. And Jenkins just reports back all the pipeline information. So everything we have showing here is also showing in Jenkins itself. So I could go to Jenkins starting page. And I will see two pipelines and use them as specific or standard pipelines as I'm used to trigger them in Jenkins and so on. So here that's the one that failed because something still already existed. And here it's just executing the other one. And I can use my Jenkins as I'm used to use it. It's just an extension here to see it all in one front end, maybe to track it. But that's up to you, how you prefer to use it. More questions?
No, there are no further questions so far. So for you guys who are attending us right now, if you have any questions, please shoot them through the text chat.
I'm curious why it does take so long. Sorry. So we should have created a new trigger. So we can look up the QA because the trigger was set there. And we have it in the deployment configuration because that's what does deploy an image as soon as a new version will appear. And we did it for front end. And we go to version, and now we see there is a trigger for the version 1.2 if that just changes, and there's a trigger for the version 1.3. So yeah, the trigger thing just happened. Now I can go to the images, and I see that there's some seconds ago there was a new version released with a version 1.3. The new version we will listen to if there's a new version. And now we have two image streams or two images in our image stream with two specific different tags. So now I will see if there did happen or if a deployment did happen. There didn't happen a deployment. So the pipeline itself finished with success, but OpenShift, for some strange reason, didn't deploy the new image, even though the new image version has been updated and there was a trigger set. Well, that's strange. well, I think I did show it that, that's what happened here, that we code and build, have a new frontend latest, take it to a not new version, and then just replace one service here. Okay, but for me, I'm very wondering why it did not deploy the new image version. Maybe. No, it's v13. So it should have listened to it. Now it should create, guess, the new version. But I shouldn't do it manually. That's a fail behavior. It might be that even though the pipeline showed a very long-term or very delayed version of what happened and took a while, that both actions just did follow up on a very short time manner, that the new set trigger couldn't respond on putting the new image there. That's maybe something I need to try out later on and refining the use case. But I still can remember that it worked at some time, so I need to figure out what changed. So if there are no further questions we could answer right now, I would thank you anyway to just join the webinar. And I would be happy to see you again in one of our upcoming next webinars to another topic.
All right, thank you so much. Thank you so much, Felix. Thank you so much, everyone, for joining today. You will receive the recorded session within the next 48 hours, along with the session that we hosted last week. So again, thank you so much. Have a great day, have a great evening, and hopefully see you soon. Bye-bye.